highly, again, horizontally scalable and fault tolerant. So already mentioned about this. Now let's take a look at how the data is organized. So the data is organized in the form of buckets, which is at the top level. And then you have the key, which is a binary blob to identify each of the values. And then you have the values, which are any and every possible data type. So this is as simple as that, just a key and the value. So you need to know which bucket, which key, and then you can fetch the value. And how does it work? A few sample code and a few commands are shown here. It's very simple. Once you install React, all you need to do is run this command React start. And then if you want to start another node, you just go to the second node and do the same, React start. And then if you want to combine these two into a cluster, you just have to run the command React admin join and React at the rate of that IP address. And you do this for each of the nodes, and that's how a cluster is set up. So it's very easy and simple to use in that sense. And programmatically, you basically use HTTP APIs. So from your program, you can access the data. There are APIs available. So this is, let's say, a difference with respect to RDBMS. You don't just do queries, but you are provided with APIs in order to access and manage the data. So here are a few API commands. So if you want to store the data, you have the post API. And if you use it without the key, React will define the key for you. And if you use put with the key, you need to define the key and provide it. So that's how you create the records, you create the data. And in order to fetch the data, you use the API get, and you mention which bucket and which key, and you will get the information. And then if you want to delete, you need to just use delete, mention which bucket and which key, and that particular record gets deleted. So these are some of the commands and APIs. So just to give you a flavor how it looks. Next we go to column family. So column family is based on Google's Big Table. And here again, the data model is pretty simple. It's somewhat like traditional databases. Only thing is that instead of storing in the form of rows, the information is stored in the form of columns. That is the basic change here. And again, there are APIs provided for querying and processing this information, this data. And some of the common examples of column family are HBase and Cassandra. Cassandra is very popular. So let's take a look at how the data is stored and what are some of the commands and sample code. So Cassandra provides, Cassandra, we are taking Cassandra as an example of a column database, and pretty much other column databases will be in a similar way. Now, Cassandra provides what is known as SQL or Cassandra query language. So once you install Cassandra from the terminal, from the DOS prompt as we call it, you can go to CQLSH shell, and in order to create a key space, you use the command create key space, give the name, and there are certain parameters about the replication you need to provide. So that creates the key space, and then you use that key space to create your tables and column families and so on. So in order to create a column family, you go to that particular key space. In this case, let's say my key space, and you say create table, the name of the table, and then you provide the columns that you want to add. So basically this is known as a column family. We normally don't refer to it as a table. So you create a column family with the required columns, and that's how you create a column family in Cassandra. Then there are a few more in the next slide. Just give a moment for the slide to appear. So as you can see, if you want to see what are the various tables that are available in this namespace or the various column families, as it is referred to in case of column database, you just simply write the command describe tables, and if you want to see what is the implicit schema for a particular table, let's say user in this case, you type describe table and that particular table name. Now you see that this looks very familiar. It is pretty much SQL commands, right? Similarly, if you want to insert records, you pretty much use the command like in SQL. So you say insert into, and then the column family name and the values that you want to insert. And then if you want to fetch the records, again, this is very familiar, especially for all the RDBMS folks. Select star from and the table that you want. As simple as that. And similar commands are there for update and delete. So as I said earlier, it doesn't mean we don't use SQL at all. So we do, in some instances, we do use. Okay. So what else? Next is document databases. And here again, the data model is in the form of, at the top level, you have databases, then you have collections, and then you have fields. The collections are the equivalent of tables in traditional database, in traditional RDBMS. And the fields are basically the values that we store, and this is stored in JSON format. Many of you may be familiar. JavaScript object notation, or binary JSON, or BSON as we call it here. And the most common examples of document databases are CouchDB and MongoDB. One of the common usages of this is analyzing maybe blog posts. So unstructured data you take and then analyze it. The next slide, wait for it to refresh. Basically, some sample code again. So you have, let's say, in this case, we are taking MongoDB. So let's say you installed MongoDB and you want to start creating tables and records and so on. So one way of creating a table is to do it explicitly, but typically, in case of MongoDB, a table gets created when you do a first insertion. So here we have an example. Sorry for that. So here we have an example. Just checking if you can see the slides.
Mohan, I think there's a problem with your network. You just got disconnected. So can you please log in again?
Let me just check.
Your audio is very much there. It's just that, yeah, you have logged out.
Okay, let me just check that. Session shows as I'm in, so shall I close and relog in?
Yes, please relog in. You don't need to disconnect from the call. You can just relog in because the audience is able to hear you.
Right.
They cannot see the screen.
Okay. All right, yeah, let me just restart the webinar session.
I request all the audience to be online. Mr. Kumar would be back online very soon.
Yes. Yeah, should be there in a minute. Yes, I think I'm back on.
Hello, Mohan. Can you hear me?
Yes, I can hear you. And can you see my slides?
Yes. Your slide is very much visible. It's sample code commands. You can continue with the presentation.
Thank you very much. Hello, everyone. Sorry for the interruption. So we are on the MongoDB sample code. So what this slide shows is basically a couple of lines of sample code. If you want to insert or create the table in a column database like a MongoDB, there are two ways. One is you can explicitly create it. At the bottom, there is a create collection or create collect. And you give the name of the database, users in this case. Or it can happen automatically when you're inserting your first record or document. That's what's shown on the upper side of it. So that's how we create a collection family in MongoDB. There are other commands or APIs, which is basically to query the data. So for example, fetch will fetch all the records. This is equivalent of select star in traditional databases. And then of course you have update if you want to update a particular record. You get the update with the particular record that you want to update and the values with which you want to update. So this is sample code for updation. Then we have graph databases, which are basically used or very helpful, very powerful when we are creating something like a social media application. And this is also based on graph theory. And here the data model is quite different from others. There are nodes which basically are the primary objects, if you will, and then you have edges and properties. And we are all familiar with these kind of graphs like we have in, for example, Facebook or LinkedIn and so on. We have a person and he has several friends, and then he has a network of friends and so on. So that's the kind of applications where this is extremely useful. And Neo4j and Infinite Graph are some of the common graph databases. And what we'll do is we'll take a look at Neo4j in a little bit more detail. In general, in a graph database, it is very whiteboard friendly in the sense